Hello everyone. Hello everyone. I hope everyone can hear me. So now we are starting with the live marathon of S2 past papers. And let me just double check one thing. First of all, okay, so I hope it's all audible for you all. And let's just wait for a second. So now we'll be discussing some papers and some key concepts. So let me just do one thing. Not this over here. Now over here, the thing is, we are starting with this idea of S2. So now in S2, there are the major topics. Of course, you know them. That is Poisson, linear combination, CRV, sampling and estimation, and hypothesis. And type 1, type 2 error is part of hypothesis. So let's take this paper, May, June 2023, variant 62. And let's look at the questions. Let's go one by one. The first question, it says, in a survey of 20 randomly chosen students from a certain college, it says 23% says that they own a car. So now it says calculate an approximate 93% confidence interval for the population, for the proportion of students from the college who own a car. Now, first of all, this is about confidence interval. And yesterday, I took a class of my students and I did something over there. I think there was this thing. There was a PDF that I made. So let me just focus on this. I think it was M1 and S2, something like this. So I'm just waiting for it. I think that's the one. Yes. So these are the notes from yesterday. Just have a look. This is the theory of Poisson distribution. This is about linear combination. This is about sampling and estimation, focused on sample using random numbers. And this is about some of the theory and then a detail about CLT. So, and then unbiased estimates. And then the formulas for confidence interval. So basically, we are using the formula on the right in blue color. So let's move on. So now the question says, confidence interval for population proportion, that is equals to PS plus minus Z square root PSQS over N. So now 93% confidence interval, 93% is in the middle, and 7% divided by 2. That's 3.5 on the sidelines. When we read the Z value, we read for 96.5%. That comes out to be 1.811 or 812. That is from the normal distribution table, the Z table. Now, what do we have? We have N as 200. We have probability of success, PS. Let me write a symbol S over here. So this is PS is this much, QS is this much. And then we have the Z value, which is 1.811. So the Z value is 1.811. And then we plug everything into the formula. And these are the two things that we obtain. So that is the lower bound and that is the upper bound. So that is a pretty basic question. Can you show the method on how to reverse the work after confidence interval? That's right over here. This is 93%, 93 plus 3.5 is 96.5. Go to the table, read 0.965, and this is the corresponding Z value. If you're asking about this, this is the thing. Question number 2, and if it's something else, you can write in the comments. And if there is a question that's coming up, which most probably will, I'll show it over there. Now it says the random variable W has a Poisson distribution. W follows a Poisson distribution with lambda. State a relationship between EW and variance of W. So now it's a property of Poisson distribution that the mean and variance should be the same. Now it says the random variable X has the distribution on binomial n comma p. J wishes to use a Poisson distribution as an approximate distribution for X. Use the formula for Ex and variance of X to explain why it is necessary for P to be close to 0 for this to be a reasonable approximation. Now, this is a very nice question. Now, first of all, expectation of X is NP, variance of X is NPQ. And we know that if n is greater than or equal to 50, let me put the greater and equal sign over here. I think I just missed out the equality. Greater than or equal to 50 and NP is less than 5. So therefore, the binomial will become a Poisson. So now NPQ and NP should be the same. So this is NPQ. So if this is 1, therefore 1 minus P is 1. Therefore, P should be as small as possible. Do you get the idea? We know that NPQ and NP is the same. So this is NP, this is NPQ. Q is written as 1 minus P. Let me write 1 over here. NP, NP cancel. So 1 minus P equals to 1. Therefore, P is equals to 0. Of course, if it's 0, things cannot happen. So it has to be as small as possible. So that's a very, very logical question that they have asked. Given that Y has a distribution such and such, that is 20,000 and this much, use a Poisson distribution to calculate an estimate value of Py greater than 2. So now N, P, this is 1.4. Both conditions are fulfilled. So N is greater than or equal to 50 and NP is less than 5. Therefore, Y follows a Poisson distribution with 1.4. And probability Y greater than 2, that becomes Y greater than or equal to 3, which is 1 minus probability Y less than or equal to 2. The rest of the working is known. Now, someone has asked this question. The questions where the percentage of confidence is not given and they have asked us to find it. Yes, such questions will probably be there when I'll be moving to next paper. So now this is a good question. Question number 3. This is about the basic thing. The masses in kilogram of newborn babies in country A are represented by the random variable X with mean, mu, and variance sigma square. The masses of a random sample of 500 newborn babies in this country were found and the results are summarized. N is given, sigma X is given, sigma X square is given. Calculate unbiased estimate of mu and sigma square. So unbiased estimate of population mean is the same thing as sample mean. Unbiased estimate of population variance, it's n over n minus 1 sample variance. Use this formula. I prefer to use this formula because it always makes me realize that n over n minus 1 will be greater than 1. So therefore, this thing will always be greater than s square. Alternatively, this formula is there. It's your choice. And then it says, a researcher wishes to test whether the mean mass of newborn babies in a neighboring country B is different from that of country A. So the word different means it's a two-tailed test. That's right over here. He chooses a random sample of 60 babies in country B. Find the sample mean is this much. Assume that your unbiased estimate in part A are the correct values for mu in this thing. So assume also that the variance of the masses in country B is the same as this. Carry out the test at the 1% significance level. So that's a traditional question of hypothesis. First of all, do any justification that is necessary. What is the justification? It does not say that it follows normal distribution. Sample size is large and is greater than or equal to 30. CLT applies. Next thing, write down the distribution for sample mean. This 3.25, that is this one from the previous part that we are using. And over here, 0.766. So basically, unbiased estimate of population mean and unbiased estimate of population variance, that goes over here. And this 2.95 is the sample value. It's a two-tailed test. Calculate the z value, that is negative 2.655. The significance level is how much? 1%, divide equally 0.5%, 0.5%. And then you read for 99.5%. That is 2.576. Z calculated value lies in critical region. Reject H0, accept H1. Yes, there is sufficient evidence at 1% significance level. At 1% significance level, to accept the claim that mean mass in country B is different from country A. So you have to write in the context of this question. So the context is very necessary. That is the first thing. It's also necessary when you are rejecting H0, you should write that there is sufficient evidence. If you're not rejecting H0, you should write insufficient evidence. Mention the significance level, and then, of course, the words in the context of the question. Now, that person who has asked this thing about confidence interval, let's say this is a confidence interval question, whether it's about X bar, whether it's about PS, and then you use the width formula. And if a question like that comes, of course, I'll mention it. But since this thing is there, let me use it. 2Z, and then let's say it's PSQS over N square root. And we find the value of Z as this much. Let's say the Z comes out to be 2.576. So don't jump into conclusion that 2.576 means 99.5%. No. 2.576 on the left is 99.5%, on the right is 0.5%. 0.5% on the right, 0.5% on the left, that is 1%. Therefore, in the middle, we get 99%. That is exactly the concept that we use in confidence interval. The next question, just read the question so that I can sip some tea. It says the number X of books received at a charity shop has a constant mean of 5.1 per day. State in the context one condition for X to be modeled by a Poisson distribution. Now, there are 4 conditions for Poisson distribution, and they all are related to mean number of occurrences in a specified time or space interval. So now, first of all, the mean number of occurrences should be occurring at a constant rate. The mean number of occurrences should be occurring singly. They should be independent. They should be occurring at random. So now we are talking about the number of books received. The number of books received at a charity shop should be received independently, should be received randomly, should be received singly. Constant rate was already mentioned. So now there are some favorite questions. So why don't you take a screenshot? So this is one of my favorite questions. Let me minimize it. So take a good screenshot so that you remember exactly which question to refer to. By the way, this is May, June 2023, variant 62. And you can also take the screenshot later from the video itself. So now this is one of my favorite questions because this basic idea is being asked. And that first question also was a very nice one. Assume now that X can be modeled by a Poisson distribution. Find the probability exactly 10 books are received in a 3-day period. So now you had this thing, which is 5.1 as the mean. You multiply it with 3, you get 15.3. Now use this 15.3 over here. Probability X is equals to 10, single value probability calculation. And this is the answer given to 3 significant figures. So again, the level of accuracy work in 4SF. So that final answer is in 3SF. Of course, in S2, you don't have to worry about any angle or something. So don't worry about that. Now the next part. Again, read this question. It says, use a suitable approximation to find the probability that more than 180 books are received in a 30-day period. So more than 180 books. So how would you get this thing? So more than 180 will come up later. Before that, we are talking about 30 days. So take 30, multiply with 5.1. That comes out to be 153. All good? X follows the Poisson distribution with 153. So now, since lambda is greater than 15, let me focus over here. So since lambda is greater than 15, therefore x follows a normal distribution 153, 153. And then probability x greater than 180. Of course, you have to do continuity correction because this is normal approximation to Poisson. So greater than 180, that becomes greater than 180.5. Standardize, you get the z value, apply the relevant rule. Greater than a positive value is 1 minus probability z less than this particular value. This is the final answer. Show every single step. The same question is continuing. The number of DVDs received at the same shop is modeled by independent Poisson distribution with mean 2.5 per day. So there is books, there is DVD. They're asking about the total number of books in DVD. X follows the Poisson distribution 5.1, that is for the books. Y follows the Poisson distribution 2.5, that is for DVDs. W, introduce a new variable, that is the total. You can write T, you can write W, any of your choice. So W follows X plus Y, this is 7.6. Probability W greater than 3, greater than or equal to 4, 1 minus probability W is less than or equal to 3, and then you get this answer. Question number 5 looks like linear combination. Read the question first. Now, what does the question says? It says two random values of x and y have the independent Poisson distribution. And independent distribution, my bad, it's not Poisson. That was the previous question, a very long question. So now it says normal distribution 7,3. So this is 7,3, that is x, and this is 6,2, that is y. So it's pleasing to see small numbers. A random value of each variable is taken. Find the probability the two values differ by more than 2. So x minus y follows this distribution, y minus x follows this distribution. The mean was positive over here, the mean was negative over here. Let's call this as W. Let's call this as R. Probability W is greater than 2. Probability R is greater than 2. You get two different probabilities. You add it up. Now, there was a question in which when you add it up, it was getting greater than 1. So I think a better idea is this thing. X minus Y modulus is less than 2. So therefore, x minus y lies between 2 and negative 2. And then you can work it out. This is better in case the probability exceeds 1. Now, the next question, the next part, it says each candidate's overall score in a science test is calculated as follows. Let me just double check if everything is good. So now each candidate's overall score in a science test, okay, in a science test is calculated as follows. The mark for theory is denoted by T. And then it says the marks for the practical is denoted by P. And the overall score is given by T plus 1.5 P. There is T, there is P, they are assumed to be independent. These are the Poisson distribution. You should assume that no continuity correction is needed. So now, over here, why should we be doing continuity correction? Care any which way, they have already mentioned it. A pass is awarded to candidates whose overall score is at least 90. Find the proportion of candidates who pass for 5 marks. Now, first look at the working and let me know in the comment section if it's all good, all clear. We have the individual distribution. How am I playing around with the expectation? How am I moving around with the variance? So it's a game of expectation. It's a game of variance. So now over here, first of all, write things down where they belong. And over here, we have expectation of T. Let me enlarge it. So we have expectation of T is 62. Variance of T is 158, 42, 108. And it follows the normal distribution, okay? M is T plus 1.5P. Expectation of M is expectation of T plus this thing. That's expectation of T plus expectation of 1.5P. This 1.5 comes out and multiplies. And this is what you're getting. In variance, variance of a constant is 0. I think I just forgot to write it properly. Variance of a constant is 0. And just double check the result. So that result, let me use blue color over here. This is 0 and 1.5 square into 108. So I think might have made a small error over here. Let me just correct this error. Let me grab my calculator. Now, someone, I think your basic is not that strong. Where is the continuity correction? If you are asking about this question, there is no continuity correction. If you were asking about the previous question, so yes, there was continuity correction. We already did it. Now, some people, they ask this question. That means they have not studied very, very well. That is, which topic is the most frequent? What is the predicted paper? People, everything in S2, this is A levels that we are doing and not some other educational board. Everything is important. Keep that in mind. So you cannot like think about it and then work it out in some other way. So now let me just multiply this out. I need to correct this thing. That is 1.5 into 1.5. That is 2.25 into 108. So yes, this comes out to be 243. So there is a small error over here. This is 243. I'm just doing the correction. So let me write it with white color. That is 243. And over here, no. One more thing, my bad. That was not variance of a constant. That was variance of t. So I think it was all got all clear. So variance of t was given. That was 108. Now, these kind of things happen when you are looking at the comments on YouTube and then you are working out things over here. So let me ignore YouTube for right now and let me just focus on this. And if it's something very, very important, I'll look at it later. So now let's move on. That is expectation of M is this much, variance of M is this much, variance of 1.5. Let me just emphasize on it. If it was like variance of, let's say, A, that would be 0. This is variance of T. So it was all good, all perfect. So now M follows a normal distribution such and such, M greater than or equal to 90, and Z is greater than or equal to such and such, and then you get this answer. Comment on the assumption that the variables P, T and P are independent. Now, what are they? They are the marks. P is the mark for theory. P is the mark for practical. Do you think they are independent? I don't think so. If someone is a good student and he's studying a particular subject, so theory and practical cannot be independent. Very, very unlikely. So now question number 6. It says when a child completes an online exercise called MathLit, they might be awarded a medal. The publisher claims that the probability that the randomly chosen child who completes this thing will be awarded a medal is 1/3. Asha wishes to test this claim. She decides that if she is awarded no medals while completing 10 this quizzes, she will conclude that the true probability is less than 1/3. Now, this last statement, I want you to read it again because such a statement defines the critical region. Got the idea? Read it once more. Asha wishes to test the claim, and then she says what? She decides that if she is awarded no medals while completing 10 quizzes, she will conclude that the true probability is less than 1/3. That means this statement over here, it is for the critical region. So the critical region is x is equals to 0. Why? Because she will be rejecting H0 and she will be accepting H1. Because overall, it was 1/3, and now she is claiming she will conclude true probability is less than 1/3. She will conclude to reject H0. She will be accepting H1. So the critical region is that no medals, that is x is equals to 0. So that is the main thing, critical region, x is equals to 0. Let me highlight it over here. This is the most important part. So whenever we are dealing with type 1, type 2 error, critical region is of utmost importance. X follows a binomial distribution, probability of type 1 error, probability of critical region. That is this thing. That is also the true significance level. The other significance level, that is for comparison purposes. The true probability of being awarded a medal is denoted by P. Given that the probability of a type 2 error is this much, find the value of P. Now, that is again a very nice question, one of my favorite questions. So now this one was a real game changer paper that I'm making you solve, which is what? Which is May, June 2023, variant 62. So do have a look later at it. May, June 2023, variant 62. That is a very, very nice paper. So now the true probability of being awarded a medal is denoted by P. Now, this is the first time that they are making us calculate the probability, and that is only possible because the critical region was a single integer. Probability of type 1 error, the probability is this P. Probability x greater than or equal to 1, 1 minus probability of x is equals to 0, which is 1 minus probability of failure raised to power of 10. I can use Q and then I can subtract it later. I prefer to write 1 minus P in this particular scenario. So therefore, this minus this is this much. Make P the subject, use a calculator. So probability, the true probability is 0.2. So another very, very nice question. Now it's time for CRV. A lot of people who have weak basics in pure math 1 or pure math 3, they are afraid of CRV. Otherwise, this is a very basic chapter. Yes, sometimes it's upon the genius level of the examiner, how they are able to create such a question. So now look at this thing. That is this thing over here. That the diagram shows the graph of a probability density function of a random variable x, which takes value between 0 and 4 only. Now it says this thing that is over here. Now it says the diagram shows the graph of the probability density function of a random variable x, which takes value between 0 and 4 only. Between these two values, the graph is a straight line. Show that fx is equals to kx. That's the equation. And it says where k is a constant to be determined. So now let's move on. It says A, the area of this thing should be probability, that is half into base into height, that is A. A should be probability, which is 1, therefore h comes out to be half. It's passing through the origin. C is 0, y-intercept is 0, gradient is not half, my bad, gradient is h over 4. Half over 4, which is 1 over 8, therefore fx is kx, the value of k is 1 over 8. Just have a good look. We used the concept of this thing, which is over here, that is coordinate geometry, area under graph is 1. That's how this is obtained. And now it says, hence or otherwise find expectation of x. So now over here, this is that the x into fx, you multiply it out. And then this is kx, k is on the outside. This becomes x squared, integrate x cubed over 3 between the limits 0 and 4. And expectation comes out to be this thing. Now let's move on. Part B. Now in part B, what needs to be done? The diagram shows the graph of the probability density function of a random variable w, which takes values between 0 and a only, where a is greater than 0. So a is on the positive side, as we can see. Between these two values, the graph is a straight line. Given that the median of w is 1, find the value of a. So median of w is 1, find the value of a. So that means we have to work with this thing. So now what we can do is that this one is a different question. It's a different graph. First of all, first thing, there is D and there is A. I have labeled D myself. So half into A into D is 1. Therefore, D is 2 over A. Coordinate geometry, gradient is y-intercept is D, that we can see. And C is equals to D, that is the y-intercept, which is 2 over A right over here. Gradient is change in y over change in x, that is this thing. And that's how this equation is formed. So now again, this one was a nice question, a strong question, a very, very strong question of CRV. Now, again, I'm emphasizing on this fact that if your basic of O-level math is weak, you won't be able to handle such question. So I hope you have upgraded your O-level maths and this basic knowledge. Be very, very alert when solving these questions. It's not just about S2, it's much more beyond that. So now this thing is there. And then what is the next part? 50% of the distribution lies below median. Probability W is less than or equal to 1 is 0.5. They are saying that the median is 1. We have to find A. So between 0 and 1, this is the equation. I took 2 common. I took A common because these are constants. So 2 over A is on the outside. This is x plus 1, a straight line equation. I integrated it. So x becomes x square over 2. 1 becomes x. The limits are 0 and 1. Plug in the upper limit, plug in the lower limit, equal it to this. This 2 over a is taken to the other side. That becomes a over 4. And it's not an easy thing. You are getting answer in the third form. Choose the one that is within the range. So that is the knowledge over here. A very strong paper. Let me go to the examiner report on this particular paper because it's definitely worth it. I hope the examiner report is here. Yes, it is. So let me just clear the page for you. And since we have done every single question on this one, so it's definitely worth it to go through everything over here. So now, first of all, what I need is this thing. Is that the key messages, which is of utmost importance. So now the first thing is that in all questions, let me start underlining. So because tomorrow it's all about your nerves. How cool are you when you are solving a particular paper? So in all questions, first of all, sufficient method must be shown to justify answer. So now the way that I've explained over here, I think I have done more than sufficient method to justify answers. Second part, candidates need to work to the required level of accuracy. Now this story is there from O-level maths. And then P1, and then P3, and then S1, and then S2. That means work in 4SF, final answer 3SF. It is important that accuracy is not lost due to rounding answers to 3 decimal places rather than 3 significant figures, or to round too early in the question. If the final answer needs to be given to 3 significant figures, then all previous numerical answers need to be at least 4 significant figures. So at least 4 significant figures, that means 4 or more. So 4SF is perfect. For answers that are required in the context, whether it's about some sampling reasoning or type 1, type 2 error, the reasoning behind it, quoting general textbook statements will not be sufficient. That is part and parcel of the deal, but you need to write more than that. All working should be done in the correct question space of the answer booklet. If answers need to be continued on the additional page, they must be clearly labeled with the correct question number. Candidates should make corrections by crossing through and replacing the work. And this is the golden thing that they have written, not by overwriting the answer. Let's say someone has written in pencil. So I would write expectation of x is equals to x into fx dx between the limits a and b. I'm just giving you an example. And then someone is writing on top of it. That was pencil, the green one, and I'm writing. How does it feel? Can you read it clearly? I think that would cause mental torture to the examiner. So make sure you don't cause them any mental torture. Do not overwrite. So that is one thing. General comments. Now, let me highlight the general comments. It says, this was a reasonably well attempted paper with candidates able to demonstrate the knowledge. Well attempted with these, while question 7B and question 5B3 were not as well attempted. Now, let's double check what were these questions. So question, which ones? Question 5B and question 7B. So if I go up over here, First of all, we are over here, and that is the blue thing. And this is question 5A, 5B. People made some mistakes over here. I think I consider it to be easy. And then what else was there? Question number 7B, I think this must be the one. Yes, 7A was still easy. 7B was, yes, I would say it was tough. So people lost marks over here. Coming back to this thing. Candidates generally presented the answer well and with sufficient working. And then it says it is important that sufficient method is shown. For example, now let's start reading this. If a probability is being calculated using a Poisson distribution, then the term or terms in the Poisson expression must be seen. Candidates must note that the conclusion to a hypothesis test must be written in context and with a level of uncertainty in the language used. What does it mean? It means that we should write, let's say, if we are rejecting H naught, so we should write sufficient evidence. This has to be written at, let's say, 2% significance level and to accept the claim and so on. So when they ask this thing, do not write a blanket statement. Okay, let's accept it. No, there is sufficient evidence at this percent level, significance level, to accept this claim. And then it says comments on specific questions follow which identify common errors. Comments on specific questions follow which identify common errors, though it should be noted that there were also many good and fully correct solutions seen as well. So this is the general idea. Now, I think let's move to the next paper. And this time, let me focus on specific questions. So now this thing about random sampling, let me just go over this thing. Now, let me just have a look of this. That is over here. And let's... Okay, so let's move on. A club has 264 members, numbered from 1 to 264. So basically, this is 001, 002, and 264. Donash wants to choose a random sample of members for a survey. In order to choose the members for the sample, he uses his calculator to generate random digits. His first 20 random digits are as follows. Now, even though these we are dealing with 3-digit numbers, keep that in mind. So we would be choosing 3-digit numbers. Why? Because that is how we are going. And over here, 6 digits are given. So how do we break this up? So we break this up in this manner. So let me choose 2 colors. This is 106. And let me choose over here. This is 1 and 2 and 1. And then the next one is 180. And then let's choose 121. And then let's choose 473. And then choose 227. And then there is a 2-digit number. So therefore, it's not of any use. So the rule is, this is called sampling using random numbers. We choose numbers that are within the range. So this is chosen, this is chosen, this is chosen, this is repeat, discard. Out of range, discard. Inside range, choose. That's how this thing is there, within range and no repetitions. Very basic thing. Now it says to obtain the numbers for members after the 4th member, Donash starts with the second random digit 0 and obtain numbers such and such. Explain why this method will not produce random numbers. So it's kind of the same series of numbers. So it won't be unbiased. It would be biased. So make sure that whatever technique that we use, that should be unbiased. Now over here, this is a nice question. It's a different type of confidence interval for population proportion. Just have a look. Just read the question first. It says in a random sample of 100 students at a particular college, X students liked exams. Lucy used this result to find an approximate 90% confidence interval for the proportion of all students. Her confidence interval had a width of this much. Find the two possible values of X. So now that's a good question. What is X over here? So X is this thing, that is the number of students who like exam. So PS is X over 100, QS is 1 minus X over 100. So when I solve this question, that's the width value, that is the Z value for 95%, because 90% is in the middle, and this is 95%. And then QS is written as 1 minus PS, this is PS. So look at this working. It's full of decimals, and it's a quadratic formula is a must. You get two values, 0.36 and 0.6. So they are kind of like 0.36 is 36 over 100. And you find the value of X as this thing. So because it was X%, so 36 over 100 is equals to X over 100. Therefore, X is 36. 64 over 100 is X over 100. Therefore, X is 64. So these are the two different values. Now, another twist in this particular question, that is, Susanna independently took another random sample and found another approximate 90% confidence interval for P. Find the probability that neither of the two confidence interval contain the true value of P. So now this confidence interval, the percentage that we are calculating, the percentage at which we are calculating, that contains the true value of the mean or the proportion of success. So now this is binomial because more than one is taken. So Y follows the binomial distribution 0.90. None of these contain this. So 2C0, success raised to power of 0, failure raised to power of 2. Or if you want to write it directly, that is 10% is failure. This is also failure and this is also failure. So 10% into 10%, that is 1%. That's how you can also do it. So it's not necessary that we are getting this. Now, some people, they ask this question. I think they should be a little bit more vigilant. This is May, June 2023, variant 63. Let's move on. Focus on the question itself. You can, of course, have a look at the year a little bit later on. So let's move on. This one was a normal question. This is okay. Let's also focus on this 6 part A. It says it is known that 1 in 5,000 people in Italia have a certain condition. Random sample of this many people from Italia is chosen for a medical trial. The number having this condition is denoted by X. Use an approximating distribution. So let me write over here another one of my favorite. So something like this. Expect it tomorrow. Let's hope for the best. Is this an educated guess? Now it says use an appropriate approximating distribution to find the probability X is less than or equal to 3. So this is number of trials. This is probability of success. N should be greater than or equal to 50. And NP should be less than 5. So NP is 2.5. All set, all justified. Probability X is less than or equal to 3. And that's how this is calculated. Now, another nice question. So in 2023, they asked these conceptual questions very much. Find the values of expectation of X and variance of X and explain how your answer suggests that the approximating distribution is likely to be appropriate. Expectation of X is 2.5. Variance of X is almost 2.5. They are almost equal, and that is necessary for a distribution to be modeled as a Poisson distribution. So very nice technical question. So now some people, they asked this question few days earlier. I think let me explain this. Let me first add a page over here so that you can have a blank page and a comfort level to look at it. So now it says the random variable X has the probability distribution function F, where the graph of Y is equals to Fx is a semicircle. So now we know that the probability should be what? The probability should be the area under the graph. That's one thing. The graph should be above the x-axis because then the area will be positive, and the area cannot exceed 1. So these are few of the things. Now it says the center is 0, 0. That's right over here. And a radius is this much. So that is the radius over here. And this is one of the x coordinates. And that is the radius also over here. So this is also 2 over pi, the whole thing square root. So what are they asking? Verify that f can be a probability density function. So if I find the area under graph between 0 and this thing, the radius, it should equal to 0.5, 0.5 on this side, 0.5 on this side. No need to integrate the whole thing from this thing to this thing. That would be waste of time and energy. A and B are points where x is equals to such and such, meets the x-axis and semicircle respectively. X is 1 over pi under root. So this is 1 over pi like this. If I plug in the semicircle equation, I should be able to find the coordinates of B. Show that angle AOB is 1/4 pi radians and hence find this thing. Now the angle thing is over here. So basically I have to prove that this is an isosceles triangle. So I can prove that. That's good enough. And I think there was an extra page over there. So let me focus on this. Now let me first remove this page over here. So this thing is removed. Let's get started. So now the first thing, that is over here. Let AB is equals to, let me first start with this. First thing, area of semicircle. That is half into pi into r square. R is in the exact form. When you square it, the square root disappears. 2 cancel out, pi cancel out. That is beautiful. And the probability is 1. So that is area of semicircle. That's one thing. And if you do it by integration, then you have an issue because we don't have an equation. So area of semicircle is best. Area of quarter circle, double it. You can also do it. And then it says A and B are points such and such. Now this thing, let me work this out. This is OB. This is the radius. This AB, let me call this as the height. And this OA, that is the base. So the hypotenuse square is the base square plus h square. Look at the working. H comes out to be 1 over root pi. 1 over pi, the whole thing under root can be written as 1 over root pi. So basically, this is the next part. Hold for a second. So basically what they are saying is that we have to prove that it's an isosceles. So therefore, two sides have equal length. Make sure to write it. Therefore, it's an isosceles right angle triangle. And therefore, there is a 90-degree angle, there is a 45-degree angle, there is a 45-degree angle. Therefore, this is pi by 2, this is pi by 4, and the other one is also pi by 4. So pi by 4 and pi by 4. So over here, this one is pi by 4 and this one is also pi by 4. That is the basic logic. Now, what are they asking? They're asking that probability x is greater than this value. So x greater than this value, they are asking for this thing. That means I can find the area of the quarter circle, which would be half. Subtract from it area of the sector. Subtract from it area of this triangle, and that is the region over here. So this is like more of a pure math question. So area of triangle, half into base into height. Applying this knowledge of indices, that comes out to be 1 over 2 pi. Area of semicircle is 1. Area of quarter circle is half. Area of sector is 1/4. Why is it 1/4? Because this angle is pi by 4. This angle is pi by 4. So therefore, these two sectors are equal. Got the idea? This thing was half. This is 1/4. This is 1/4. Again, this is 1/4. This is 1/4. So I'm choosing 1/4. This is 1/4. So again, very, very conceptual question. So area of this thing is done. That is sector is 1/4. Area of quarter circle is half. So difference is that half. You can write it like this. Minus 1/4 minus 1 over 2 pi. And this is the answer. This is probability x is greater than this value, which is 1 over pi square root. So half minus 1/4 is 1/4 over here minus this thing. So very, very conceptual question. Let's do a question such as this. A new light was installed on certain footpath. A town councillor decides to use the hypothesis test to investigate whether the number of people using the path in the evening has increased. Before the light was installed, the mean number during any 20-minute interval was 1.01. And after the light was installed, the total number n of people using the path during three randomly chosen 3-minute period was noted. So basically, we won't be working with 1.01. We will be working with 3 times 1.01 because there is a 20-minute, 20-minute, 20-minute period. So that is 3.03. Now it says, given that the value of n was 6, the sample value was 6, use a Poisson to carry out the test at the 5% significance level for 6 months. X follows the Poisson distribution with this. Sample value is 6, that is inclusive. And I'll also tell you, let me just focus on something. That is about the critical region. I'm just taking you on the sidelines. That was about a two-tail thing. So let me come back to it a bit later. And then it says probability x is greater than or equal to 6, 1 minus probability x is less than or equal to 5, too many terms to calculate. And this comes out to be 8.70%. Always convert it into percentage. This percent is less than 5% significance level. Do not reject H0, except H0. There is insufficient evidence. What is the significance level? That is 5%. Insufficient evidence at 5% significance level to believe that the mean number of people for that lightning thing has increased. Now the next one, later, a similar test at the 5% significance level was carried out using another 3 randomly chosen 20-minute period. Find the probability of type 1 error. So critical region. Now greater than or equal to 6. Now someone asked the same question, so I don't have to go back. This is basically for an upper tail test. Probability x is greater than or equal to 6. That is this much. If I do probability x is greater than or equal to 7, that is 1 minus probability x is less than or equal to 6, which is this much is already calculated. I just need to add one more term from here. This comes out to be 3.51%. That means the critical region is this because the probability fell below 5% level. Got the idea? Look at it once more. Probability x is greater than or equal to 6, that was already used. I need to move in the same direction for the critical region since it's an upper tail test. So let me calculate probability x is greater than or equal to 7. Now I have to subtract it from 1 because there is no ending in Poisson. So probability x is less than or equal to 6, that is less than or equal to 5 plus probability x is equals to 6. I wrote this separately, calculated it, added to this one, took care of the percentage. This comes out to be 3.51%. Now it has fallen below 5%. Therefore, this is in the critical region. So critical region is x is greater than or equal to 7. Probability x greater than or equal to 7. That is 3.51%. And what is meant by type 1 error in this context? Reject H0 when H0 is true. So H0 is true. Lambda is 3.03. We are rejecting H0. We are accepting that lambda has increased. Now join the two statements. Concluding that the mean number of pedestrians has increased. We are concluding this when in fact it's not true. The reality is this thing. What is true is the reality. What is perception is your mistake. So the reality is this, the mean is still 3.03, but we are wrongly concluding that it has increased. Now this is written in better English language. Concluding that mean number of pedestrians has increased when in fact it is not. State in context what further information would be needed in order to find the probability of type 2 error. Whenever they ask for type 2, we would flip the critical region and make it acceptance region. And if it's a normal distribution, we need a new mean. If it's Poisson, we need a new mean. If it's binomial, we need a new probability of success. So that is the definition. H0 is false, H1 is true. Therefore, new value of lambda is needed. True mean number of people using the pathway, the footpath that is needed. So now let me just look at one question that was done some time ago. That was about a two-tailed test. Yes, there it is. So someone requested for this, and it's over here. Just read the question first, and then I'll explain it. So now this would be the last question from my side. It is not known whether a certain coin is fair or biased. In order to perform a hypothesis, Raj tosses the coin 10 times, counts the number of hits obtained. The probability of obtaining a hit on any throw is denoted by P. Test the null hypothesis. Find the acceptance region for the test, given that the probability of type 1 error is to be at most 10%. So now we have to start from both the ends because we are unsure whether the coin is fair or biased. If it's biased, it's more towards the head or more towards the tail. We don't know. So we calculate these probabilities. Probability x is equals to 0. That is 10C0, success raised to power of 0, failure raised to power of 10. Now, when we are dealing with a probability of 50%, the beautiful thing is this thing will always add up 2.5 raised to power of 10. And this is basically 10C0. This is 10C1. This is 10C2. And 10C0 is the same thing as 10C10. 10C1 is the same thing as 10C9. 10C2 is the same thing as 10C8. That is why look at all these numbers. They are coming out to be exactly the same. Now, when I add the two purple numbers, it's still very, very less as compared to 10%. If I add these two, still it's very less. But if I add this thing 4.4, 4.4, that's 8 point something, I think that's going to exceed. So whatever fits in this container, that is the critical region. Some people, they can use a number line. So I can say 10 is there, 9 is there, 1 is there, 0 is there, but 2 is not there, 8 is not there. So basically 0, 1, 9, and 10, that is the critical region. So over here, 0, 1, 9, 10, that's the critical region. So let me add a page. I need to write something more. So over here, let me draw a number line first. And over here, let me label it properly. So this is 0, this is 1, this is 2, this is 10, this is 9, this is 8. So 0 and 1 and 9 and 10, this is the critical region. So x less than or equal to 1 and x greater than or equal to 9, this is the critical region. So what is the acceptance region? That is 2 and 3 and 4 and 5 and 6 and 7 and 8. So 2 till 8, the acceptance region is x lies between 2 and 8. That is the acceptance region. Whatever lies in the critical region, the corresponding probability, that adds up to type 1 error. So therefore, probability of type 1 error is basically probability x is lesser than or equal to 1 or probability x is greater than or equal to 9. So those are the 4 percentages that we are adding. That is this percentage, this percentage, this percentage, this percentage. We added up. That is 2.147%. And calculate the probability of type 2 error if the actual value of P is 0.7. So now that is too much to calculate. So how would you calculate probability of type 2? So probability of type 2, given the actual value of P is how much? The actual value of P is 0.7. So now I need to calculate probability x lies between 2 and 7. So that is 2, 3, 4, 5, 6, 7, which is not much to calculate. Rather than subtraction, I think I would prefer that you use it. So therefore, this is 10C2. Let me just write the 2 brackets, 10C3, 10C4, and 10C5, and 10C6, and 10C7. And this is 0.7. So let me write over here 0.7 all along. And let me also deal with the powers. That is 2, 3, 4, 5, 6, and 7. And over here, let me write 0.3. That is 0.3, that is 0.3, that is 0.3, that is 0.3, that is 0.3. And the powers are 8, 7, 6, 5, 4, and 3. And when you add it all up, that is the probability of type 2 error. So I think that is a good overview of everything that we have done over the years, and wish you the best of luck, and just show all your working. Whatever I have written in the examiner report, that's more than perfect for you to obtain your A star and your A grades. Take care, everyone. Allah Hafiz.